Angle relationships and parallel lines. Let's say you have a basketball, and then you have another basketball just like it. The word we can use to compare these two figures is congruent. So these would be congruent basketballs or congruent figures, but now let's talk about congruent angles. So if we have one angle that's exactly like another angle, the exact same measure, even if we rotate that angle, if it still has the same measure, it's going to be congruent. So they don't have to face the same way or look exactly the same. They just have to have the same measure. Just like with this basketball, we could turn it around, but it's still going to be the same as the other basketball. So congruent angles, and that's our symbol right there. That's the congruent symbol. An equal sign with a little squiggly on top. They have the same measure. Alright, well that's easy enough. Now what about adjacent angles? What word do you think of when you hear the word adjacent? I think of the word next to. Think about your neighbor. Your neighbor lives, or your next door neighbor lives right next to you. And you may share a common fence or a common side of your property. So that's what adjacent means when we're talking about angles. Angles that share a common side. So angles that share a common side. And an example of that would be, let's say we drew two rays like that, and then coming from the vertex there we have another ray drawn. So this angle right here and this angle, I'm going to call this one angle A and angle B. Angle A is adjacent to B because they share the common ray, and that common ray is going to be what I'm denoting with this green mark here. They share that common side. So those two angles are going to be adjacent. They're next door neighbors. They're good buddies. Alright, so not all next door neighbors are good buddies. Well, we tried. Alright, vertical angles. When you think of the word vertical, you think of up and down, right? So these angles could be up and down from each other, or opposite of each other. And maybe I need a spelling lesson. Whoops. Opposite of each other. And they share a common point, or they share a vertex, we could say. And they are formed by intersecting lines. Now the cool thing about vertical angles is they are congruent. And I'm going to use that congruent symbol. They are congruent. And the reason that's so cool is you can just glance at them and know that they're equal to each other. So if you make any intersecting line, let's make the letter X. Alright, I know when I make that letter X that my angle 1 and my angle 3, and I know my angle 2 and my angle 4, they're opposite of each other. So they're going to be the same measurement. So that's pretty cool. So any intersecting lines, opposite angles are going to be the same. So we'd say angle 1 and 3 are vertical. So that means they are congruent. And really I should say that like this. Angle 1 is congruent to angle 3. And I can say that what? Angle 2 and angle 4 are congruent. And what's the reason? Because they're vertical. You have one on top of the other. So see, they're sharing this common point, and angle 2 and angle 4 are opposite each other. Angle 1 and angle 3 are opposite each other. And I've heard somebody say it kind of looks like a bow tie if you look at angle 1 and angle 3. So the bow tie relationship is what I've heard it referred to as. Alright, another important thing I want to talk about is naming angles. You want to name angles by using 3 letters. And this is most of the time. So sometimes you won't have 3 letters to pick from, but if you do, use those 3 letters. And the middle letter is the vertex. And that always needs to be the case. So we're going to talk about supplementary angles, and I'm going to model how to name supplementary angles now. Alright, so supplementary angles, they are 2 angles that add to 180 degrees, or their sum is 180, and they make a straight angle. So anytime it looks like they're making a straight line, or it doesn't have to look like it, they need to make a straight line, they're going to be supplementary. So let's do an example of that. So for instance, if we had, just make a straight line with arrows at the end. Hopefully yours is a little bit straighter than mine. And then I'm going to have a ray coming off of it to the right. And I'm going to put a few points on there. I'm going to put a point to the left over here, a point where those lines intersect, or the ray and the line intersect. I'll put a point on this ray and a point over here. And I'm feeling extremely creative right now. I'm going to call that A, B, C. Hey, I told you I was feeling creative. Ooh, that one's a Z. Wow, Mr. Simon. Creativity's just flowing out of you right now, huh? Alright, so we have A, B, C, and Z. So what would be supplementary to what? Let's name these angles. Well, I would say angle A, BZ, angle ABZ is supplementary to angle ZBC. And notice my only vertex here is this angle. I'm sorry, this point, point B. It's my only vertice here, is right here. So I'm using that as my middle letter when I name these angles. So I could have called that first angle, let's talk about what I could have called it. I called it ABZ, representing this angle right here. I could have also called it ZBA. That represents the same angle as long as I put the vertex in the middle, which is what I did. Same thing for the other angle. It's ZBC, that's what I named it. I could have also called it CBZ. Either way, it represents this small acute angle here, and that the ABZ represents the obtuse angle here. So they add to 180 degrees. So for instance, if ABZ equals 110 degrees, so let's say then what do you think angle ZBC would have to equal? Well, we know they both had to add up to 180, and I already have 110 degrees right here, right? I just called that 110. So take away 110 from 180, and we're left with 70. There we go. So 70 degrees is what this angle must be. Angle ZBC. Alright, so that sums it up for supplementary angles. Now the next group of angles, they're very nice. And I mean extremely nice. Good role models. Yeah, please pause the video if you need any more time copying that, because we're moving on to complementary angles. So if one angle complements another angle, you're cute. And the angle accepts, why thank you. Then the angles are doing the right thing. In other words, they're making a right angle. That's a 90-degree angle. So that brings us to our term complementary, and this is actually spelled with an E, not an I. So complementary angles. Two angles that form a right angle or 90 degrees. So two angles whose sum or who add together to make a 90-degree right angle. See? Angles are so nice to each other. We could take a lesson from them. Alright, and we'll do an example with complementary. Let's make one angle going straight up and down, and then a ray going out from that. And then I'm going to draw one that's diagonal, but a little more towards the top. I'm going to put some different points on here. I'm going to put a point up here and call it C. This one down here is D, E, and then this one over here is F. And you need to have that box there to show that it's 90 degrees. So if that's 90 degrees there, then I know that, think of the angles. That's angle C, DE. D is my vertex, so it has to be the middle one, is complementary. I'm just going to abbreviate. Complementary to, how would you name that other angle? Angle EDF. So let's say, for instance, that angle EDF was 58 degrees. Then we could just do 90 minus 58, and 90 minus 58 gives us 32. So that means that would have to equal angle CDE. So if you know one, you can find the other just by subtracting from 90. Alright, and just to recap, angle CDE represents this small, skinny, acute angle. We could also call it angle EDC. So that middle letter has to be our vertex D. And on the other angle, angle EDF, that could also be read angle FDE, as long as D is our middle letter. And they're complementary, they add up to 90 because they're doing the right thing. Way to go, angles. Complementing each other and accepting. Alright, that brings us to our next topic. Alright, start out by drawing two parallel lines, like I've done right here. And then you're going to take another line, and I'm going to run it through like so. That blue line is called a transversal. And on my parallel lines, I'm going to put little arrows on them to show that they're parallel. These little arrows designate that they're parallel. And the blue line I'm going to call is my transversal. So I'm just going to put a little arrow to that and call that the transversal. And a transversal is just a line that cuts through parallel lines. And I'll call that cursive letter L. So L is my transversal. Alright, now I'm just going to number these angles. So 1, 2, 3, 4, and then 5, 6, 7, 8. So go ahead and number those with me. And the cool thing about this is, I think it's pretty cool that half of the angles are going to be the exact same measurement, and then the other half are going to be another measurement. So in other words, there's only 2 different measurements on all 8 of these angles. So only 2 different angle measurements. For all 8 angles. I think that's pretty cool. And if you know one of their measurements, you can find them all. Which again, I think is pretty cool. So the easy way out is just to look at them and see which ones are acute. And we'll say all acute angles are the same. All acute are congruent. And you might have guessed it, if all the acute ones are congruent, then all of the what? Obtuse angles are congruent. And we'll talk about why in just a second. So angle 4 is acute, so is angle 2. And they're vertical angles, aren't they? What about over here? Angle 8 is acute, and so is angle 6. What other rules did we learn? If they make a straight line, they are what? Supplementary. Look at angle 8 and angle 5. They make a straight line, so they are supplementary. That means they add up to 180. 5 and 6, they make a straight line, or a straight angle, so they add up to 180. So see, once you find one, you can find them all. Alright, just a couple of terms. First term is corresponding angles. They're on the same side of the transversal and in the same position, and they're congruent. So for instance, and I'm just going to circle these. So angle 4 is on the bottom left. If I were to call these 4 angles, I would call this one the bottom left. What one over here is on the bottom left out of this group of 4? Angle 8. So I'd say angle 8 is going to be corresponding to angle 4. That means they're congruent. I'm going to circle some more that are congruent. Angle 3 is on the bottom right. Look over here in this group of 4. Angle 7 would be on the bottom right. So just put a couple examples there. We could say 4 and 8, and then 3 and 7 would represent 2 examples for corresponding. Alright, and then alternate interior angles are on the inside, and they're on opposite sides of the transversal. So if we look back here, look at, for instance, 2, 5, 8, and 3 are my 4 angles that are on the inside. 6, 7, 1, and 4 are the 4 angles that are exterior or on the outside. So these 4 are facing inward. So out of these 4, 2 and 8 are going to be an example. So I'm going to write those down. 2 and 8 would be alternate interior. And let me add that alternate interior, they are congruent. Make sure you have that down. So 2 and 8 are congruent. And what's the other pair that are going to be alternate interior? Well, look at 3. It's on the bottom of the transversal. 5 is on the top. So they're alternating sides of the transversal, and they're both inside. So 3 and 5 would be the other ones. Alright, we're not going to write it down, but alternate exterior is the same deal. That's the outside angle. So like 6 and 4 would be alternate exterior, and then 7 and 1. and they're going to be congruent as well. All right, that wraps it up. Thanks for watching.